Hi friends, my name is Praveen and today I am going to speak about the energy stored in a capacitor and energy density of a capacitor. Then let's start. Consider this is our parallel plate capacitor. It is connected to a battery. That is, it is connected to a V volt battery. The capacitance of the parallel plate capacitor is C. And as we all know, the battery is connected to the capacitor means there will be a charge accumulation inside the capacitor. The accumulated charge inside the capacitor is Q. Okay. Then let's go for the basic definition of potential. We have learned potential as V is equal to W by Q. And from this we could write W is equal to V into Q. In this case, the initial charge is 0 and the final charge is Q and the charge is accumulating inside the capacitor. We are considering the small work done, that is dW is the small work done in charging the capacitor by an amount of dQ. That is, I could write, since V is equal to W by Q, I could write dW is equal to V dQ. And dW is the small work done in charging the capacitor by an amount dQ. Then from this small work done, we could find out the total work done. And we will be using integration. That is, W is equal to integral of V dQ. We could write W is equal to integral of V dQ. And by the definition of capacitance, we know C is equal to Q by V. Therefore, V is equal to Q by C. I am substituting for this V. W is equal to integral, instead of V, Q by C dQ. Then if we are taking constants out of this integration, C is constant. 1 by C is taken out, integral Q dQ. As we all know, the basic expression of integration, that is integral of x dx, it will be x raised to 1 dx and the answer will be x square by 2. Likewise, integral of q dq, it will be 1 by c, q dq will turn out as q square by 2, and this is the total work done. And this total work done is stored as potential energy. That is, the energy stored inside the capacitor is q square by 2c. This is one expression for energy stored inside the capacitor. We could transform this expression by using, we are having the basic expression of capacitance as C is equal to Q by V. Therefore, I could write Q is equal to CV. And if I am writing Q is equal to CV, and if we are substituting it over here, this equation can be rearranged as C square V square by 2C, that is CV square by 2. And CV square by 2 is another expression for energy stored in the capacitor. Next, let's substitute for C in this equation. Since C is equal to Q by V, if we are substituting for C in this equation, we could get Q by V into remaining over here V square by 2. Therefore, we will get QV by 2. Therefore, this is the third expression for energy stored in the capacitor. Then you could recall the expression for energy stored in the capacitor as U is equal to Q square by 2C, U is equal to CV square by 2, and U is equal to QV by 2. These are the expressions for energy stored in the capacitor. Now that we have derived the energy stored in a capacitor, that is U is equal to Q square by 2C, CV square by 2 and QV by 2. Let's derive the expression for energy density. For that, what is energy density? Energy density is energy stored per unit volume. That is, the energy stored in a unit volume of capacitor is called as energy density of the capacitor. And energy density is denoted by the letter small u. Small u is equal to total energy divided by total volume. We could obtain energy density by dividing energy with volume. Then what's volume of the conductor? Volume of the parallel plate capacitor will be the capacitors of plate area A and distance between the plates is D. Therefore, volume will be area of cross section into distance. Volume is area of cross section into distance. Then we can use the expression for energy. I am writing it as capital U. Energy as CV square by 2. I am using this energy's formula, for which we know the capacitance of a parallel plate capacitor is epsilon 0 A by D. This is the capacitance of a parallel plate capacitor. If I am substituting for C, we could write V square by 2 instead of C, epsilon 0 A by D. Then we know potential is equal to electric field intensity into distance of separation. Potential is equal to electric field intensity into distance of separation. Therefore, if I am substituting for this V square, I could write all the rest terms are epsilon 0 A by 2D. Instead of V square, it should be E square D square. Then we could see this D square and D, one D will get cancelled, and the energy stored formula is transformed as, that is, epsilon 0 A E square D by 2. This is expression for energy. Then if I am substituting for U and volume in energy density, we could write the energy density's expression, that is small u is equal to, instead of capital U, we are substituting this epsilon 0 A E square D by 2 divided by volume. Volume is A into D. Then it can be written as epsilon 0 A E square D by 2 into AD. Then A and A, D and D will get cancelled. As a result, we are getting the expression for energy density as epsilon 0 E square by A and A will get cancelled, D and D will get cancelled, epsilon 0 E square by 2. This is the expression for energy density. Energy density is energy stored per unit volume. The energy stored in a capacitor is Q square by 2C, CV square by 2 and QV by 2. Energy density of a capacitor is half epsilon 0 E square or epsilon 0 E square by 2. Energy is normally denoted by the letter capital U, and energy density is denoted by the letter small u. You should also remember the formula. Energy density is energy stored per unit volume.